Hi everyone. Today we did 4-3B as our warm-up, so I'm going to review that with you. So if you look at for 3B, you have an area model. Let's draw that in your notebook. And you're going to write the area as a sum and as a product. The area as a sum would just be all of these tiles together. So for example, if I had built this with tiles, I'm going to quickly build this with tiles. I'm actually going to film as I build this. So there's 5 XY tiles. Not sure how to make a rectangle right now, but I'm kind of organizing these the way that I think they're going to fit together. So 5 XY tiles, and then there's 2 negative Y tiles. So I'm putting those together. So you should have this written in your notebook. 5 XY tiles, 2 negative Y tiles, 15 X tiles, and then 6 unit tiles, and they are negative. So if you're really wondering, what are you doing with all of this? The reason I'm going back and building it with tiles is to kind of help you connect it to what we did in chapter 1. And then instead of building it with tiles, we are actually using an area model. So the area model only says, whoopsie, let's try that again. Thought if I held down the shift key, it would make it a straight line. Oh, maybe not. Okay. Okay, that's the area model that we see in our book. Now it doesn't look like that, but because it's not drawn to scale, but here's the 5 X's. Here's the 15 X tiles. Here's the negative 9 unit tiles, and here's the negative 2Y tiles. So what we're doing is we're writing the area as a sum, which would just be all of these. You're basically listing what tiles you have. You have 5 of these, you have 15 of these, 15 X tiles, you have negative 2 Y tiles minus 6. So that's our sum. Normally we're dealing with a quadratic expression. This particular one is not a quadratic expression. And then to write it as a product, we're going to write the length times the width. Well, if you look at, and this is on the main Schoology page in the purple folder that says resource pages, if you look at tiles with dimensions, it shows you the length and width for all of these tiles. So if I look at the XY tile, that has the long side is Y, the short side is X. So on this area model, this would be, that's the longer side. So that's actually Y. This is the shorter side. So that's actually x. And then for the x tiles, the short side is 1, the longer side is x. So this would be 1, this would be 1, this would be 1. And you could do it on this side too. The longer side is x, so each of these is x. You don't have to. Or you could do it on this side. Each of these is x. Okay, and then this is the short side for the y rectangle. That short side is 1, the longer side is y. These happen to be negative, so this would actually be -1 and -1. And then we don't have to do the top, but this would be y, and this would be -1, -1, -1. This would be -1, this would be -1. So if you're kind of stuck on one side, maybe look across from it, is what the point that I'm trying to make here. Okay, and then for the product, you're just going to write the length times the width. So your length would be this side right here, which would be y plus 1 plus 1 plus 1, which would be y plus 3. Your height, your width, would be x plus x plus x plus x plus x. Well, that's 5x. And then you've got -1 plus -1, so that's 5x minus 2. So then your product would be y plus 3 times 5x minus 2. That's your product. So that goes in for the warm-up. So please enter that into the Desmo screen for warm-up. For part C, we did I built it with tiles. Okay, draw that in your notebook, and if I go too fast on the video, just pause it. I'm going to pause this and heat up. Okay, for part C, we've got the area model, and you don't have to use tiles. I used tiles because someone had a question about how are you getting this product, and so I'm trying to show you where this product is coming from. So we're moving away from tiles, but if you need to see the tiles, here they are. You've got whoopsie, that was kind of messy. Okay, let's clean this up a little bit. Okay, so this is for 3C. We have 12 x squared tiles. We have 16 x tiles. We have -9 x tiles, and we have -12 unit tiles. And we are writing the area as a sum and as a product. So the sum is just writing out all the tiles that we have together. So that would be 12x squared. Now I could write these separately, but if I have 16 x tiles and -9 x tiles, so I'm going to show you. Okay, maybe not. Let's see. There we go. Okay, if I combine these together, -x and +x, that's going to cancel out, right? So that means these 9 x tiles are going to cancel out 9 of these positive, these negative 9 X tiles here are going to cancel out positive 9 tiles. So those are going to be gone. So these cancel each other out, and what's left is this right here. So 7x. So for the sum, I'm just going to write 12x squared plus 7x, because negative 9 plus 16 is 7, minus 12. For the product, what we did in class is we didn't use the tiles. We just said, what can we multiply to get 12x squared? And we realized that 6 and 2 wouldn't work, because while 6 and 2 multiply gives me 12, 6 is not a factor of 16. It's not a factor of 9. I can't put 6 down here, so we had to pick something else. So we went with 3 and 4, and 3x has to go right here. 4x has to go right here. Now, if you use the tiles, you can see that. So let's move these back over here. Oops. So if I am using tiles, then I can just say, okay, what's the length of this side? This is x, this is x, and this is x. So that would be 3x. This is x, this is x, this is x, this is x. So that would be 4x. So we did it without tiles, but somebody had a question about how are you getting this. So that's why I built it with tiles. And then if it helps, you can put 4x over here. 4x times 4 is 16x. 3x times, you can put the 3x up here if it helps. 3x times what is negative 9x? That's going to be a negative 3. And then we wrote the area as a product. So I would like you, for the check-in screen, to write the area as a product and as a sum. So I want you to do both of those. And then I'll check it. And then for the last question, we did it kind of quickly. Some people had more time to look at it than others. But this last question says that this student, Casey, she was working on this and she noticed something and she drew these diagonals. So my question for the exit is, do you notice something about, what do you think that she noticed? Why did she draw the boxes around the diagonal terms? So for the exit, if you see the pattern, type it in the exit. If not, that's okay. And that will be it for today.